Hey, welcome back, students. In this video, I want to go ahead and talk to you a little bit about decomposition reactions. And so decomposition reactions, as the name implies here, is going to be a reaction that is going to decompose. Okay, and so what this really means is that you're going to have a generic reaction. So let's go ahead and write this down. A general reaction, usually some kind of compound. And we'll just represent it generically here as A and B. So A represents the cation, B is the anion, and it will essentially break apart into the cation A and the anion B. Okay, it's the general formation. Now this is assuming, of course, that this is a soluble compound, is the way it's going to decompose. Okay. There are other ways that we can get decomposition. Decomposition can also be achieved if we have some kind of catalyst. And that catalyst is generally referred to or identified here when we have this. The catalyst is generally referred to up here above the reaction arrow, and so we usually put it here. Okay. Now, let me just make reference here. The catalyst can be a compound, it can be a substance, an element. It can also be heat that is applied, it could be heat removed. So all of these are going to be things that can affect a chemical reaction. In this case, we'll do an example. So let's go ahead and do one here with heat being applied. And so I'm just going to do a very generic example here. Okay, so this is going to be calcium carbonate. And we're going to cause this to decompose with the addition of heat. And notice here I'm putting the triangle right here to denote heat. And so let me just label that appropriately for you. Okay. And so that there refers to heat. And the decomposition here that's going to occur is going to be that you're going to form calcium oxide and carbon dioxide. Okay, so it's not important to worry how this happens. Just know that it is one of the ways that calcium carbonate is going to decompose. When you add heat, it'll decompose into these two products. Okay, and so what you need to be able to do then is to obviously balance this. And so let's just go ahead and check that out, because one of the things that you need to know, not only in identifying that this is a decomposition reaction, is that you can also generate the balanced form of the overall reaction. And so here we notice that we've got one calcium on the left, one on the right. And so just to make sure that we're all on the same page here, when I say left and right, I'm actually referring to various spaces or various things here. And so what I'm going to do is I'm going to go ahead and change colors here. And let's just designate that when I'm referring to everything on this section over here on the left, this is referring to the left side of the reaction. And on the right side of the line is referred to as the right side of the reaction. And so remember here that right refers to the products, and the left here refers to the reactants. And so it's just important that I make sure that we specify this from the get-go. And so here now we notice we have one calcium on the left, one calcium on the right. We have one carbon on the left, one carbon on the right. And so that means that we're going to have to look at the oxygens last here. 3 oxygens on the left. There's 1 oxygen on the right in the calcium oxide, and then 2 oxygens in the carbon dioxide, for a total of 3. So this particular reaction is balanced. And if I were to put the overall coefficients here for this would be a coefficient of 1, 1, and 1. Now, I should mention that when you're doing problems like this, you may be asked to identify them, and a lot of the problems are going to be multiple choice. So if you are provided a multiple choice problem, for example, you got 1, 2, 3, and 4, you want to go with the answer or the choice here that will give you the right number of coefficients. So I'm just going to make up some coefficients here. Let's say some coefficients here are essentially 1, 2, 1, or 1, 1, 1, or 2, 1, 1, or 1, 1, and 2. And so let me move some of this out of the way. Not quite, didn't quite work. Okay, and so if we do this, notice here that if we look at the coefficients, we have a coefficient of 1, 1, and 1. So the correct answer choice here, if we were looking for an answer choice, the answer choice here would be answer choice 2. And so just make sure that you're aware of that. Sometimes the problems that you encounter on in exams, quizzes, sometimes they ask you to give the right coefficient sequence, or they can ask you to give the sum of coefficients. So the sum of the total coefficients of this reaction would be 3. You can also be asked, what's the sum of the coefficients for products, in which case the answer here would be 2 for the products, because you would then add up the 1 for the calcium oxide and 1 for the carbon dioxide for a total of 2. Okay, so just be aware that those are ways that, or question types that you can achieve or get on a exam or quiz. All right, so let's turn our attention here and let's kind of do another problem. I'm going to go ahead and clear out the board and erase a lot of the stuff that I've got written down here. Let's erase the... All right, so here is the reaction that we're going to be looking at. Okay, and so that reaction is the following. And so we're going to take KClO3, potassium chlorate, and this reaction is going to decompose into two products, KCl and oxygen gas. Okay. Now notice I'm not putting any of the identifying phases at the bottom yet. Eventually we'll get all of that here as we continue in the course, but for right now, do know that this is a decomposition reaction. Knowing again how it decomposes is really not important at this point, only that you can see that you've got one big huge compound and it's being broken up into two parts. And so that by definition is the decomposition of a compound, okay? Or decomposition meaning it decomposes, it breaks apart. Now the other thing that you got to be aware of here is that we are going to be using this with applied heat, and we are going to add a catalyst. Let me go ahead and erase this at the bottom. Okay. And the catalyst that we're going to use here is MnO2. Let me see, I don't know if I came out okay, so let me fix that. MnO2. Okay, and so with the manganese dioxide, these are little chips. They look like little rocks, and you put them in, add a little heat, and what will happen is that the KClO3 will decompose into these two things. You'll generate gas. It'll be a bubble, and typically it's the gas here, the oxygen, that we're trying to capture, and we can use that in other reactions that we're trying to utilize, so that we don't have to essentially come up with oxygen applied. We can just create it in the reaction. Okay, and so the idea here is once we go forward, obviously we do need to make sure that at the end of this, once we've identified that this is a decomposition reaction, which it is, just go ahead and do the double check here and make sure that everything's balanced out. All right, so if we do that again from before, remember that we've got the left and right side. So here on the left side, I'm just going to put it down here at the very bottom. This is your left, this is your right. Remember, right is for products, left is for reactants. And so we'll start at the very far left. We've got one potassium here on the left, one potassium on the right, one chlorine atom on the left-hand side, one chlorine atom on the right-hand side. And so it comes down to the oxygens. Notice here the oxygens here give us 3 oxygens on the left for the reactant side and only 2 oxygens on the product side. And so this is going to be a problem for us. Typically what we want to do is we want to make sure that we can get a multiple, and that both of these are going to be the same at the very end. So my usual rule of thumb is whenever I see an odd number, I usually double that. And so what I'm going to do is go to double that there. I'm going to say KClO3. I'm just adding another copy of it. And notice what happened here is if you look at the numbers, notice here that if we do this, now we've got a total of 6 oxygens here on the left-hand side. And so what's left for us to do is to kind of make sure that we got the same number on the right-hand side. And so notice we've got 6 oxygens, 3 and 3. So we'll have to come over here to the oxygen gas on the right-hand side and add multiple copies there until we get the 6. And so if you do that, notice now the total here is going to be 6 oxygens. Okay. Now, that doesn't mean that this is completely balanced, because when we added another copy of KClO3, what we did is we increased the number of potassiums and chlorines. Now we've got 2 potassiums and 2 chlorines, so that means we need to turn our attention to the product side of things. And notice here we've got 1 potassium, 1 chlorine, so we'll need to add a copy here of that compound, and that should give us the 2 that we need. So when we're done here, when we do all of this, what we need to do is now count the copies that we've added. This method that I'm using here is just essentially a visual method, so you can just count them. There's one copy, there's two copies, so the coefficient here should be a 2. One copy of the KCl, two copies of the KCl, so the coefficient there is 2. And then for the oxygen, there's 1, 2, 3 copies, and so the coefficient there is 3. Now, if this were a multiple choice problem, clearly here you want to go with the answer choice that is going to give you a coefficient sequence of 2, 2, and 3. Okay, and so that would be the option that you look for. Okay, if they're asking you for the sum of the coefficients on the products, then you would say here 5 is equal to the sum of the coefficients of the products. Okay, so two separate examples of how you can see this on a quiz or an exam. And so hopefully that was useful for you. Keep watching, keep learning, and if you haven't already done so, subscribe, and we'll see you in the next video.